Welcome you all. I am Dr.N.S. Senthur, Assistant Professor, Department of Mechatronics and Bharat Institute of Higher Education and Research. Course name is Non-Destructive Testing. Course code U18OEMT002. And today's topic is overview of NDT. First of all, we are going to look at destructive testing. First of all, we need to know what will be destructive testing and non-destructive testing. That only we can find out which is the type of the destructive type and which are the non-destructive type. So in that destructive type of testing, the component or specimen to be tested, it's destroyed and it cannot be reused. That is the first major difference in DT and DT. Then after testing, the component or specimen either breaks or remain no longer useful for the further use. As the name suggests, destructive testing (DT) includes methods where the components or specimen is broken down in order to determine the physical and mechanical properties such as strength, toughness, ductility, and hardness. And the destructive type testing is more suitable and economical for mass production, as the cost of destroying a small number of pieces is will be reduced, and it is not economical to do destructive testing where only one or very few items are to be produced. The examples of the destructive testing is already the basics testing methodology like tensile stress and then compressive stress and shear stress. These are the very basic testing methodologies. And the hardness test, and if you want to know that the impact test, as well as sharpening method, you can use to find it that material strength and bending stress and fatigue test, creep test, and torsion test, and chemical analysis test. These are the majorly we are using destructive type testing examples. Then what is meant by NDT? Before that, we learn what is meant by DT, destructive type. Now we are going to see about NDT. NDT, it stands for non-destructive testing. Okay, it's a name implies non-destructive testing means testing of material without destroying them. So in that type, we are not going to be destroy any material. Okay, without destroying, we are going to be find out that material, what having and everything. The testing is we are going to be find out without destroying. That is NDT's major advantage. And the non-destructive testing is an examination of an object which will not produce any kind of damage or destruction to the sample, and after testing the material can be reused. So after that experiment also we can use that material. It's also the second major advantage of the NDT, non-destructive testing method. See, in destructive testing we cannot able to reuse it. Okay, that is the major difference between the NDT and DT also. Then definition. So generally we have some definition of NDT, that non-destructive testing is the process of inspecting and testing or evaluating materials, components, or we can tell it assemblies of discontinuities, or we can tell it differences in characteristics without destroying the serviceability of the part of our system. Okay, so in that material we can inspect and test and evaluate the components, okay, or assemble or discontinues or differences in characteristic without destroying the serviceability of the part of the system. It is meant by NDT. Okay, in order the words, when the inspection is completed, the part can be used. Already we told that. So these two major advantages are be having in NDT method. Okay. So the NDT is produced, which covers the inspection and, or we can tell it, testing of any materials, component, or assembled by means which do not affect its ultimate serviceability. Okay. These are the definition of NDT. Then what are the objectives of NDT? See, the objective of non-destructive type testing, the material shortening. Okay, it's used, we can, material shortening can be created, then material characterization we can find out, and property monitoring. So materials property we can monitor it, and thickness measurement. It may be defect or whatever. With the materials thickness, we can find out use of the NDT. And let's see, for the fifth one is we can deflection or deflect detection or location. So defect detection or location we can find out. Then not only location detection of defect, we can find out the defect characterization. So how much deep it was be there, what are the types of defect is be there, that also we can find out use of NDT. The major task of NDT is to be defect and identify the range of defects. That is the major objective of NDTs. Then you can split it main objectives like to defect internal or surface flaws. Okay, that is the main objective of NDTs. Then to measure the dimension of the specimen. Okay, not only thickness, everything we can find out for the given specimen. And to determine the material structure or chemistry. In this material, what type of structure it have, that also be find it. Then to evaluate the materials, physical or chemical properties. So these are the points or the objective of NDTs. Then uses of NDT. So we know what the difference between NDT and DT. Now we are going to see what uses of NDT. In uses of NDT, flaw detections and evaluation. Okay, we can find out the flaw detection and we can find out the evaluation of that defect. That also we can find out. Then leak detection. See, is there any pipelines or whatever this is the oil pipelines? If there any leakage is there, use of NDT, we can find out the leakages. Okay, the location determination. So where it was there, we can also find out the location of crack or something defect or whatever we can find use of NDT. We can find out which particle it was there in that location. We can find out use of NDT. Then dimensional measurement. So dimensional measurement. So what size the defect is there, or what if you have any object inside of the pipeline or whatever be. To find the measurement use of NDT, so many methods are there. In that method used, we can find the dimension of that object also. So we can find dimensional measurements related also be used. Then structure and microstructure characterization. So that also we can find the use of that NDT. Then estimation of mechanical and physical properties. Yes. So the use of NDT, we can find out the mechanical and physical properties. Then stress or strain and dynamic response. It's also been already we said that so much of tests are we are going to do. So that stress and strain dynamic response also use of the NDT, and measurements and material shortening and chemical composition determination. These are all you can find use of the NDT. Then majorly the brief intro of NDT. The NDT or non-destructive testing allows the part and materials to be inspected and measured without damaging them. Okay, so that's a major point. It won't be damage the object when we are being inspected the object. Okay, because it allows the inspection without interfering with the product's final use. Okay, so NDT provides an excellent balance between quality control and cost effectiveness. Okay, so NDT it give a cost effectiveness and quality control that also be given. Some major advantages of that NDT. Then the NDT evaluation, non-destructive evaluation, NDE means it terms that is often used interchangeability with NDT. However, technically we can say NDE, non-destructive evaluation, okay, is used to describe the measurement that are more quantitative in nature. See the example I mentioned here, and NDE method would not only locate a defect, but it would also be used to measure something about the defect such as its size, shape, and orientation. NDE may be used to determine the material properties such as fracture, toughness, formability, and other physical characteristics. Okay, non-destructive test NDT and NDE. Now the difference now you can understand, right? So NDE means non-destructive evaluation, NDT non-destructive testing. Okay, in terms that is often used interchangeability with NDT. Okay. When are the NDT method used? There are NDE applications at mostly any stages in the production or life cycle of the component to assist in product development. See, the NDT methods that we use means the production time and life cycle of the component. These are the major important role in industry. So in that particular point, NDE is applicable. Okay, to resist or to assist in product development. Okay, not assist, to assist in product development and to screen or short increasing materials and to monitor or improve or control the manufacturing process and to verify proper processing such as heat treating and to verify proper assembly and to verify inspect for in-service damage. Okay, see NDE is mostly used in production industries. See, in that way only we can assist of product development. So product we can, if you improve the product, like what that any damage find or something, whatever with the development related product development, we can use the NDE method. Okay, then if maybe find out the material shortage that we can find. So in raw material, if it is shortage, that also we find because of use of that NDE method. And I continuously monitor the control manufacturing system. So nowadays everything is related to that is automation. So in that period of time, we can find the use of NDE method. Okay, Then verify the proper processing and heat transfer or heat treating. So we can find out the materials heat. Use of one of NDT method, thermography method used to, we can find what are the heat treating is going on that material. That also we can find it. And then proper assembly also we can find it. If maybe any have cracks or leakages or some gap is there, that also we can find use of NDE method. These are the NDT method used in industry. Then applications of non-destructive type testing to ensure the product integrity and reliability. See, so we can ensure that product integrity and reliability. And next one is to control the manufacturing process. So product development, okay, then manufacturing process. That's also the very important role uh, acting in that application of NDT to lower production cost. Okay, so it's reducing that the wastages. So production cost may be because of the application of NDT, it may be lower, and to maintain a uniformity in quality level. So the use of NTT, we can avoid the cracks and gaps and leakages, flaws, okay, damages. So we can improve the quality or maintain the top level quality uniformity. So that is the major applications of NDT. NDT test can be performed during manufacturing and after manufacturing, even a part that already in service. So total entire process entities are being using. See, manufacturing time also be using, after manufacturing inspection time also be using, and service time also be using. So NDT is used in all the duration, okay, in manufacturing or after manufacturing or service. Then inspection of raw products. See that inspection follows secondary process, okay, and in service damage inspection. Then inspection of raw product, if you see forging, casting, and extrusion. In that time only we can see so much of flaws are happening. So in that process, forging and casting and extrusion, in the inspection NDT method used to reduce the flaws. The inspection following the secondary process, what are those? The machining, welding, grinding, and heat treating and plating. Machining, you know, right? So use of lathe something, CNC machine components we can use to machining that process. Okay. Then welding, join the two materials. So grinding also you know, and heat treating also you know, and plating also you know. Okay. In this the process inspection time, the particular defects we can find use of NDT methods. Okay. See, inspection for in-service damage. The in-service damage what means cracking. Okay, the heat treatment sudden cooling, the cracking may be happen. Okay, or additional load if you are going to the cracking may happen. So in that cracking, if it is minor level or major level, we can find use of NDT method. Okay, in that inspection is supposed to be cracking, corrosion, and erosion or wear, how much happen, and heat damage. These are the inspection for in-service damage. Okay. The features of NDT. Using NDT, an entire production lot can be inspected. Okay, not small, lot level, the highest one, small level can be inspected. Or sometimes selected samples can be inspected. Okay, so use of NDT, we can check lot level also or selected samples. So both are we can. check use of NDT. Also, different tests can be applied to the same item, either simultaneous or sequentially, and the same time can be repeated on the same specimen for additional verification. And it may be added that the NDT equipment is often portable. Okay, this permits the use of NDT method for on-site testing in most locations. Okay, the NDT does not permanently alter the specimen being inspected. It is high valuable technique that can save both time and money in the product evaluation, troubleshooting, and research. The NDT makes components more reliable, safe, and economical. So these are the features of NDT. So the different tests can be applied because simultaneous and sequentially it happen. That's also one of the major features of NDT. And NDT is portable. We can use anywhere. Okay. Then on-site testing also is most allocation. So we can use anywhere. These are the major features of NDT. Then advantages of NDT. The equipments are easy to handle. Okay, these are the equipments we can use easily, and defects can be detected without damaging the component. Okay, then methods are quick and accurate. So we can these NDT methods used to we can find the defects, or we can easily inspect, quick, and the results will be very accurate. That's one of the major advantages of the one of the NDT methods. Okay. Components can be shorted out on the basics of electrical, magnetic, or chemical properties. The test results and other information can be conveniently recorded on paper films, cassettes, and floppies or DVDs, etc. We can save the result. That's only we are going to fill it here. So use of nowadays we have in systems hard drive, we can save it. Okay. So these are the advantages of NDT. Then difference between the major difference initially first initial slides we seen about and learn about the destructive type, and after that we learn about that NDT, non-destructive type. So now we are going to see about the difference between DT and NDT. Okay, so NDT used for finding out defects of material. So if in destructive type, they use for finding out the properties of the material. So these are the major differences in destructive type test. Use of you can find only that materials properties, not to get defects of the material find out that. Okay, these are the major first difference between destructive type and non-destructive type test. Then second one is destructive type test. Load is not applied on the material. See, in destructive type test, load is applied on the material. You already studied about that. Destructive type test is under the examples: tensile, compressive, torsion. So all the testers are the applying the load. That's why we can find out the material's properties, not their defects. Okay. So in that non-destructive type, we are not going to apply any load. We are applying load only in destructive type test, DT. Okay. Then third major difference between that NDT and DT, no load applications. So no change for material damage. Yeah. The previous thing continue only, the previous point continue. See, when we are applying the load, what will happen? That material structure may be changed. Okay, here the NDT method, we are not going to apply any material. So what will happen? The material structure, it will not be changed. But destructive type test, due to load application, material gets damaged. See, we are applying that load, right? So what happened? The material structure definitely changes. Okay. So definitely it will maybe the material structure may be damaged. Then fourth point, no requirement of special equipments. See, in that NDT method, we don't need special equipments. Okay. But in destructive type, we need special equipments are required. Okay, comparing that, is there no additional equipment is needed in NDT, but DT we need additional equipments. And moreover, the non-destructive test, non-expensive. It was a little bit cheaper comparing DT. So in the destructive test, it was be very expensive. Okay, the component is somewhat costly. Okay, but in the non-destructive type, it was be less or non-expensive. Then the operating people, if you want to operate that entity method, the skill level is not much more. Less skill level is enough to check the entity method. But if you are operating the destructive type test, that people have need more skills. Okay, the skill level required is destructive type is more and non-destructive type is less. Example, if you see in NDT, dye penetration test, ultrasonic radiography test. These are the NDT test methods. One of the methods are the, I'm explaining, it has so much of method. That one of the method is, some of the methods, major method is dye penetrant test and ultrasonic and radiographic test also be easy to operate. Okay, but in destructive test examples already shown that the first to these two slides we learned that tensile test, compressive test, and hardness test. If you want to operate this test and check the inspect the test, we need highly skill is required. Then now we go over the visual inspection. What's going to be visual inspection? So here we are going to say about visual inspection is the simplest, fast, and most widely used in non-destructive testing method. So NDT is one of the method is visual inspection. We've seen last slide so much of inspection method, but it is somewhat difficult. It's a basic method, which is a visual inspection method, very easy and fastest method. So what the visual inspection method is carried out with the naked eye or unaided or using some optical aids. It's called BIHER. See, that have two methods in visual inspection. One is unaided, another one is aided. Unaided means naked eye, directly we can see. Aided means optical use. What are the opticals means, such as like mirrors or magnifying glasses and microscopes. Okay, so if you are using mirrors, magnifying glasses, and microscopes, you are using, that's come under by the aided method. Okay, because we are using opticals. So in visual inspection, it have two types. One is aided, another one is unaided. Aided, if you are using mirrors, magnifying glasses, microscope means that's called by aided. Naked eye directly you are seeing means that is called unaided. Okay. Now we see about the definition of the visual inspection method. The visual inspection is defined as the examination of material or component for conditions of non-conformation using light and the eye alone or in conjunction with various aids. Okay, then visual inspection often also involves shaking, listening, and feeling, and something even smelling the component being be inspected. So you know, right? Visual inspection we can use the that inspection shaking also we directly we can see because eye only we are going to be using the unaided method. Okay, or if it is an aided method also we can find out that smelling, shaking, listening, okay, we can be inspected. Visual inspection is commonly employed to support other entity methods. It's the visual inspection, not only it's used all the methods. Okay, it's a very basic method, and the visual inspection we are using in all the other methods also. That's only is commonly employed to support NDT methods. The other NDT methods require visual intervention to interpret the images obtained while carrying out examinations. At some point, all NDT methods fall back on visual testing. See the example, liquid penetration testing use dyes that rely on the inspector ability to visually identify the surface indication. The digital detectors and computer technology have made it possible to automate visual inspection. This is known as a machine vision. See now you know that machine vision means what? The digital detector and computer technology have made it possible automatic visual inspection. Okay, so it's called by machine vision. Okay, the characteristics of visual inspection that only we are going to say about here. The visual testing is commonly used, okay, to detect the surface characteristics such as surface finish, scratches, cracks, colors, and wear and corrosion. To check alignment of mating surfaces, to check of the component, to check evidence of leakages, to check internal side defects. See what are the major, see that NDT you already know and NTE we know. So in this method, one of the first basic method is visual inspection method. In the visual inspection method, we are using commonly in all NDT methods and to detect the surface characteristics. Okay, surface finish we can find out how much will be there. We can use of aided or unaided method. We can easily find out the finishing of the surface and scratches. So no need to waste any equipment. Most we no need to waste some money. Okay, easy to we can see use of aided or non-aided method. The what are the scratches happen in that material and cracks, minor cracks. Okay, or colors and wear and corrosion. And we can check that alignment of mating surface. So if you have two materials connecting the time, assemble the time, what are the defects have, we can directly we can see use of aided method. And to check of the component. Okay, the correct component only we are going to be connected or not. That we can find out use of directly aided or non-aided in visual inspection. And check the evidence of leakage. Okay, if the defect is something happened, we can directly see that evidence, what are the leakages are there. That also we can find out using the visual inspection method. And to check internal side defects, that also we can find use of this visual inspection method. And The advantages of the visual inspection. What are the advantages? Direct visual inspection method or aided or unaided method. What are the advantages? Already we've seen that entity advantages, but in specifically now we are going to see about that visual inspection methods advantages. It's simple and easy to use. Okay, it's the first basic advantages here. It is simple and easy to use. The second one is relatively inexpensive. Okay, so no need to spend so much of money in that inspection. Relatively, it must be inexpensive. Okay, then testing speed is high. When you are using aided method or unaided method, the testing speed is very high. We can easy to inspect because visual inspection, we can find out that okay, whether they good or not. We can easy to find out that testing speed is high, and testing can be performed on components which are in service. Okay, testing can be performed on component which are in service. Okay, in service time also we can check. Okay, that permanent records are available when latest equipment are be used. Permanent records are available when latest equipments are be used. Then almost all materials can be inspected. So we cannot able to tell it that this type of metal only we can check it and this type of not we cannot able to check. Not like this. So here the visual inspection method we can check any type of material. Okay, if it is aided or unaided, we can easy to check all the type of material we can inspect. Then what are the disadvantages of the visual inspection? You see, limited to detection of the surface flaws. There's some limited to deflection of the surface flaws. And second one is the test results depends on skill and knowledge of tester. Then third one, eye resolution is weak. And fourth one is eye fitting. Here, that unaided method, mostly we are using naked eye. Okay, we are going to inspect in neck. So that eye resolution, that is very much needed. If you have a somewhat problem in eye, we cannot able to tell it was with defect or not. So that eye resolution, that eye fatigue is the major role happen in visual inspection. And second one is the major is the results depends on skill and knowledge of tester. If the tester not having that much of knowledge in that finding defect, then they cannot able to inspect. So in these people it have must good knowledge and skill level is higher needed to inspect the object in visual inspection method, and limited to determination of surface flaw. See, we cannot able to look it in that minor cracks, we cannot able to find it. Okay, so we can find only use of visual inspection. It have some limitations. Okay, some limitation we can see or we can inspect the defects in visual inspection method. These are the disadvantages of the visual inspection method. Then types of visual inspection method. It classified on basics of use of aids used or already unaided or direct visual testing or aided visual testing. Okay, these are the two major types of visual inspection method. The first one, unaided or direct visual testing, mean as the name suggests, the unaided visual testing is carried out with naked eye without using any optical aids. Okay, so here unaided method, you are not using any optical aids like magnifying glass or mirrors or telescopes, whatever the microscope, nothing we are going to use here. Directly we are going out the carried out the naked eye. Okay. So the most important instrument in visual inspection is human eye. So unaided or direct visual method is the most important inspection. What the instrument is the human eye one. Okay. Then what are the then now we see about the visual inspection method differences. Okay, now we are going to see about yes that equipments aided visual testing method. That aided visual testing method use of what that magnifying glasses, mirrors used to we can check the in cracks and defects. That's called by aided visual testing method. Then equipment used in visual inspection method. What are the equipment we are using here in aided method? The opticals aided used for visual inspections. These are the magnifying mirrors. Maybe it's small or angular mirrors, whatever the that's a magnifying mirror. Then second, magnifying glasses, eye lobes, and multi-lens magnifiers. Measuring magnifiers is already come under the magnifying glasses type. Then microscope, maybe that optical microscope or electron microscope. So the microscopes also be using in visual inspection aided method. Then boroscopes and fiber scopes and videoscopes. Okay. Then telescopes. Then periscopes and optical comparators and optical flats. For surface flatness measuring purpose, it's using in the visual inspection method. Then photographic recorders. Then closed circuit television, CCTV system and machine vision system and image enhancement, computer analysis and enhancement. So these are the major equipments used in visual inspection method. In aided visual inspection method. So already we discussed two types of inspection in visual method, that is aided and unaided. In that unaided, directly we are using naked eye. Aided, we are using some optics or opticals. In that opticals, now only we see the majorly, one more time I am telling that, magnifying mirror, magnifying glasses, microscopes, and the microscope it have optical and electron, and boroscope, and fiber scopes, and videoscopes, and telescopes, periscopes. So then optical comparator also here we are using optical flatness, because it used to we can find that flats measurements, the surface flatness, if you want to check it invisibly, use optical flats that we can find out that flat measurement. Okay, it has some limitations. We cannot able to tell it clearly because that I already said that visual inspection method have some restrictions. Okay, then photographic records, then closed circuit television CCTV system also be used in visual inspection. That nowadays we are using mostly in CCTV. Then machine vision system. To slides 2-3 slides before we see that machine vision system means what? How we are using in ENDT. Then image enhancement, computer analysis is used for that. Those are the equipment used in visual inspection. Then application of visual inspection. In that inspection of cleaning in machines. Then checking for corrosion and erosion and deformities of machine components, and checking of repairs cracks and wear of parts in the equipment, and monitoring the manometers, pressures, and temperatures, and monitoring of oil level, greasing and greasing apparatus, monitoring of operating conditions of system or machine, and visual testing of wells, and visual testing of pumps, and visual testing of hydraulic system, and visual testing of belt pulleys, and visual testing of forging discontinuous. So these are the major application of visual inspection. See example. Now we are checking corrosion happen any material, any what that boiler or whatever be, that we can find use of naked or aided visual inspection method. That places was be used. And welding. See welding time, if it is not a minute level, the major level, if it is joint or not, if you want to find it, use of this method, you can check and find out. Then visual testing of pumps, if it is working or not, the water is flowing or not, that we can no need to use any equipment. Directly in any, we can use it and find out the water flowing or not, any leakages are there, any cracks are happened in the pipeline, that we can find out use of this testing method. Then visual testing of hydraulic system. That hydraulic system, the pipelines, any leakages have been happened or not, that we can find out that visual inspection method. And forging discontinuous, that also we can find out the visual inspection method. And see that the pressure and temperatures level, if you use any material or any methodology, that time the results and we use can see in that visual inspection method. Already I told visual inspection method, we are using not only particular NDT method, we are using all the NDT methods. It's come under that visual inspection method. So in that the basics type of the visual inspection and application of the inspection method. See in that NDT, first of all, we learn about overview of NDT. We learn what is meant by DT. Restricted type means what? That only we learn here. And application of DT. And what are the major methods, like examples, what type of that DT methods, examples, that we learn. Then second, NDT method. What is meant by NDT? That also we will learn. And NDE. What is meant by NDE? And what the uses of NDE? That also we discussed. Then finally, we discuss the difference between the NDE and NDT. Okay. See, already we told that NDE method or NDT or DT method differences. When we are applying load in DT method, we are not applying any load in NDT method. So deformation not happen or structure change not happen in NDT method. DT method, it may be changed. Okay, that is the major disadvantages of DT method. In NDT method, we can reuse the inspected materials, we can use it one more time. But DT method material, we cannot able to use it. Next, we will study about or discuss about the visual inspection. In the visual inspection, it mentioned that two major types. One is aided, another one is unaided. Unaided, directly use of naked eye, we can inspect. Then aided, use of some opticals like magnifying glasses, mirrors, and microscopes. Everything we are using that. These are the overview of NDT method. And These are the applications of NDT method. Thank you.